Okay, so continuing in vector functions, this is section 13.2, derivatives and integrals of vector functions. So the derivatives of vector functions are defined just like our derivatives were in single variable calculus. So dr dt is defined as r prime of t, which is the limit as h goes to 0 of the vector r of t plus h minus the vector r of t all over h. And so what that also tells us is then that the limit as h goes to 0 of f of t plus h minus f of t all over h would be then f prime of t, the limit as h goes to 0 of g of t plus h minus g of t all over h is g prime of t, and the limit as h goes to 0 of h of t plus h minus h of t all over h. I apologize, that should be, yes, h goes to 0, h prime of t. So as we can see in figure 1, our secant vector is the vector r of t plus h minus the vector r of t all over h. And then the tangent vector is then defined as r prime of t. So if r of t is defined as f of t, g of t, and h of t, or f of t I hat plus g of t j hat plus h of t k hat, and f, g, and h are differentiable functions, then r prime of t is the vector f prime of t, g prime of t, h prime of t, or f prime of t I hat plus g prime of t j hat plus h prime of t k hat. There is one other vector that is defined, and it is the unit tangent vector, which is then going to be r prime of t over the magnitude of r prime of t. And again, that unit tangent vector will have a magnitude of 1. So let's take a look at example 1. So given r of t is 1 plus t cubed I hat plus t e to the negative t j hat and sine 2t k hat, we want to find r prime of t. So r prime of t is going to be, we know that this will be 3t squared I hat plus, and we need to use the product rule for this one, so it's going to be e to the negative t plus, that'll end up being minus t e to the negative t j hat plus 2 cosine of 2t k hat. Let's go ahead and simplify that. That's 3t squared I hat plus, this is e to the negative t times 1 minus t j hat, and then 2 cosine 2t k hat. Okay, so now that we have r prime of t, we want to find t of t when t equals 0. So r prime of 0 is going to be 0 I hat plus e to the 0 times 1 minus 0, so that's e to the 0 j hat plus 2 cosine 2t, so cosine of 0 is 1, so that becomes 2 k hat, and then I'm going to go back and change the e to the 0, becomes just 1. So let's fix that. So 0 I hat plus 1 j hat plus 2 k hat. The magnitude of r prime at 0 is going to be the square root of 1 plus 4, or the square root of 5. And so then our unit tangent vector at 0 is going to be the vector 0, 1 over square root of 5, and 2 over square root of 5. Okay, so if u of t vector and v of t, also a vector, are differentiable functions, c is a scalar, and f is a real-valued differentiable function, then these following derivative rules apply. So the sum and difference rule number 1, the constant multiple rule, and are similar to what we have seen. Rule number 3 is f of t as a real-valued differentiable function times the vector u of t becomes a product rule just like what you're familiar with. F prime of t, the vector u of t, plus f of t times the vector u prime of t. But there are also 2 additional product rules that involve the dot product. So the derivative of the dot product of u of t dot v of t is u prime of t dot v of t plus u of t dot v prime of t. And the same rule applies for the cross product. We have u of t cross v of t, so u prime of t cross v of t plus u of t cross v prime of t. And then the last is very much like the chain rule. If we have a differentiable function as one of our functions in the vector functions, we still apply the chain rule, and it's u prime at f of t times f prime of t. So an integral, as we remember from single variable calculus, the integral from a to b of the vector r of t dt is the limit as n approaches infinity from 1 to n of the vector r at t sub I delta t, which then shows these limits as f of t, g of t, and h of t. And so we can see that our integral of r of t from a to b is the integral of f of t I hat, the integral of g of t j hat, and the integral of h of t k hat. So given r of t is 2 cosine t plus sine t plus 2t, we want to find the integral of r of t. So the integral of r of t dt is going to be the integral of 2 cosine t dt I hat plus the integral of sine t dt j hat plus the integral of 2t dt k hat. So the integral of 2 cosine t dt gives us 2 sine t I hat minus cosine t j hat plus t squared k hat. And this is an indefinite integral, so we know that there is some constant vector. We can then use our position at r of 0, so this is r of t, and we know that r of 0 would be 2 sine of 0 I hat minus cosine of 0 j hat plus 0 k hat plus our constant, which is going to be 0. So we have then that this is 0 I hat minus j hat plus 0 k hat plus our constant vector equals 0, 0, and 0. And so we can see that our constant vector must be our j vector. And so we have then that r of t is 2 sine t I minus cosine t j plus 0 k plus j hat. And then we will go ahead and combine our terms. And so r of t becomes 2 sine t I hat plus 1 minus cosine t j hat And 0 k hat, I apologize, that's not 0 k hat, that should be a t squared. That is a t squared, and so that's a plus t squared k hat. And your question at the end of the video is going to be to find the vector when t equals pi over 3.